नमस्कार स्टूडेंट्स, मैं डॉक्टर संजय खाकिल आज आप लोगों के लिए ऑपरेटिंग सिस्टम में यूनिट 4 का एक बहुत इंपॉर्टेंट टॉपिक लेके आया हूँ, कैश मेमोरी। कैश मेमोरी होता क्या है, क्यों हम कंप्यूटर ऑपरेटिंग सिस्टम के अंदर हम इसको यूज में लेते हैं। कैश मेमोरी एक मेन मेमोरी होता है जो पर्टिकुलर किसी भी फ्रीक्वेंसी को सेंट्रल प्रोसेसिंग यूनिट में स्टोर करके उसको एज कैची मेमोरी के रूप में एज ए प्रोसेस को इजीली एक्सेस कर सकते हैं पर्टिकुलर किसी भी डेटा को शॉर्टेस्ट टाइम में। तो इसको क्या बोला जाता है, कैश मेमोरी बोला जाता है। कैश मेमोरी एक नेसेसरी एक्सेस मेमोरी होता है जो पर्टिकुलर किसी भी कैश मेमोरी के साथ में कैश टू कैश काम करता है। दूसरा, इसके अंदर जब कोई किसी भी तरीके का कोई भी डेटा अगर नहीं मिलता है तो हम कैश मेमोरी को चेक करते हैं। कैश मेमोरी फिर मूव कर जाता है मेन मेमोरी के अंदर, जिसको हम सेकेंडरी मेमोरी बोलते हैं। आगे हम डायग्राम के थ्रू इसमें देखेंगे। तो सबसे पहले हम डिस्कस कर लेते हैं द डेटा और कंटेंट्स of the main memory that are used frequently by CPU are stored in the cache memory so that the processor can easily access the data in a shorter time. Whenever the CPU needs to access memory, it first checks the cache memory. If the data is not found in cache memory, then the CPU moves into the main memory. Cache memory is placed between the CPU and the main memory. The block diagram for cache memory can be represented as, किस तरीके से रिप्रेजेंट करते हैं। नंबर 1, जब हम बात करते हैं CPU होता है जो बाइट और वर्ड्स को ट्रांसफ़र करता है, सेंड करता है, रिसीव करता है। इसके पास में कैश मेमोरी के पास में, कैश मेमोरी से हम किस में जाता है, रिक्वेस्ट मेन मेमोरी में, जो ब्लॉक ट्रांसफ़र करने का काम करता है। इसे क्या कहते हैं, हम कैश मेमोरी कहते हैं। The cache memory is the fastest component in the memory hierarchy and the approach the speed of CPU components. Cache memory is organized as the distinct set of blocks where each set contains a small fixed number of blocks. दूसरी चीज़ जब हम बात करते हैं तो कैश मेमोरी एक लॉजिकल ओरिएंटेशन होता है कैश मेमोरी का, जो 4 वे एसोसिएटिव कैश मेमोरी होता है, जिसमें ब्लॉक 1, 2, 3 और 4 इसको बोलते हैं एसोसिएटिवली, और एक सेट्स होते हैं 0, 1, 2, 3, 4, 5 n-1 n-2। ये लॉजिकल कैश एसोसिएशन होता है। दूसरी चीज़, एज इन अबव सेट्स द रिप्रेजेंटेड बाय द रो, द एग्जाम्पल कंटेन्स n सेट ऑफ ईच सेट कंटेन्स 4 ब्लॉक। व्हेनेवर एन एक्सेस इज मेड टू कैच, द cache controller does not search the entire cache in order to look for a match. Rather, the controller maps the address to the particular set of the cache and therefore search only the set of the match. दूसरी चीज़ हम बात करते हैं, if a required block is not found in that set, the block is not represented in the cache and cache controller does not search in the further. This kind of cache organization is called set-associative because the cache is divided into distinct set of blocks. As each set contains 4 blocks, and cache is said to be 4-way as the associative way. Number 1, the basic operations of cache memory. 1. When the CPU needs to access the memory, the cache is examined. Another one, it is the word is to found in the cache memory, it is required from the last memory. नेक्स्ट क्या होता है इसके अंदर, जब हम बात करते हैं तो if a word addresses by the CPU is not found in the cache memory, in the main memory is accessed to read the word. A block of the word one just accessed is that then the transfer from the main memory to cache memory. The block size may vary from 1 word, the one just accessed, to about the 16 word adjacent to the one just accessed. One is the performance of the cache memory is frequently measured in terms of the quantity called hit ratio. Another one is the when the CPU refers to the memory and find the word in cache, it is a set to produce a hit memory. If the word is not found in the cache, it is in main memory and it counts as a miss. The ratio of the number of hits divided by the total CPU reference to memory pulse is the hit ratio. Level of memories. लेवल ऑफ मेमोरीज कितने तरीके का होता है? 4 लेवल्स होता है. एक होता है इट लेवल 1 होता है इट इज़ द टाइप ऑफ मेमोरी इन विच डेटा इज स्टोर्ड एंड एक्सेप्टेड दैट द इमीडिएटली स्टोर्ड इन CPU. मोस्ट कॉमनली यूज्ड रजिस्टर इज एक्यूमुलेटर, प्रोग्राम काउंटर, एड्रेस रजिस्टर एटसेट्रा. एक क्या होता है लेवल 2. It is the fastest memory which has the faster access time where data is temporarily stored for the faster access. Level 3. It is memory on which computer work currently. It is small in size and once power is off data no longer stay in this memory. Level 4. It is an external memory which is not as fast as main memory but data stays the परमानेंटली इन द मेन मेमोरी. एक होता है कैश मेमोरी. कैश मेमोरी का क्या होता है? कैश मेमोरी आर द 3 टाइप्स. मैपिंग यूज द पर्पज ऑफ द कैश मेमोरी. कौन कौन सी टाइप्स की होती हैं? एक होता है डायरेक्ट मैपिंग, एसोसिएटिव मैपिंग एंड सेट एसोसिएटिव मैपिंग. डायरेक्ट मैपिंग के अंदर क्या होता है? द डायरेक्ट मैपिंग द कैश कंसिस्ट ऑफ द नॉर्मल high speed random access memory. Each location in the cache holds the data at the specific address in the cache. This address is given by the lower significant bits of the main memory address. This enables the block of the selected directly from the lower significant bit of the memory address. The remaining height significant bits of the address are stored in the cache with the data of the complete and identification of the cache memory. Showing in this diagram. Cache with direct mapping. One is the tag, another one is the index. Then try and index like main memory. Then after index, then compare same, different, read or take data, and this is the cache memory. Showing in this diagrams. Then after the tag consists of the highest significant bits of the address and these bits are stored with the data cache. The index consists of the lower significant b of the address. Whenever the memory is referred, the following sequence of events occurs. Then after the index is first used to access a word in the cache. The tag stored in the accessed word is read. Tag is then compared with the tag in the address. If two tags are same, that indicates the cache hit. The required data is read from the cache word. If the two tags are not same, this indicates a cache miss. Then the reference is made to the main memory to find things showing in the database. Direct mapping with multi word blocks, tag, index and word in bytes, memory access from the processor. Then after the directly read, compare same and different, then showing the index value. Then this is the cache memory. Cache memory tag word 1, 2, 4, 3 and 4. Then access word in line. Then main memory accessed if the tag do not match. Then after the index part, the address is used to access the cache and stored tag in the compared with the required data fields. Then last one is the set associative. Set associative mapping. In set associative mapping, in the cache is divided into a set of blocks. The number of blocks in a set is known as the associative or set size. Each block in each size has a stored tag. The tag together with the index completely identifying the blocks. Those set associative mapping allow a limited number of blocks with the same index and different tags. An example of 4 way in the associative cache having 4 blocks in each set is shown in the following. Then this is the diagram. Then after in set associative map, one is the index of the address from the process is used to access the set. Another, the comparator are used to compare all tag of the selected set with the incoming tag. Another one is the if a match is found, the corresponding location is accessed. If no match is found, then access is made to the main memory. And last one is the fully associative memory in cache memory. Fully associative mapping. In fully associative type of the cache memory, each location in cache stored both memory address as well as data. Then this is the main memory. Then compared with all stored address, submit. The main memory is accessed if the address is not in the cache memory. One is the address, another one is the data. Then address found, address not found cache, and this is the main memory. Then fully associative mapping. When the data is required, incoming memory address is simultaneously compared with the stored address using the internal logic, the associative memory. If a match is found, the corresponding is read out. Otherwise, the main memory is accessed if address is not found in cache. This method is known as the fully associative mapping approach because the cache data is related to the main memory by storing the both memory address and data in the cache. All organization data can be made more than one word as soon as the following figures. And this is the fully associative map cache memory showing in these diagrams. Then thanks दोस्तों, अगर मेरा वीडियो आप लोगों को पसंद आया तो आप लाइक कीजिए, कमेंट कीजिए और सब्सक्राइब करना नहीं भूलिएगा क्योंकि सब्सक्रिप्शन बहुत मैटर करता है। आप लोग मेरे साथ बने रहिए, मैं बहुत ही जल्द आप लोगों के और बहुत अच्छे लेक्चर लेके आऊँ। तब तक बने रहिए। शब्द सुरक्षित, नमस्कार।